Welcome back to General Chemistry Mini Lecture Series, Lecture 12, Nomenclature, Molecular Compounds. We are going to need prefixes in this lecture. So we have 1 through 10. That's basically those indicate the number of items in a formula or in a molecular compound. So with 1 we say mono, 2 we say di, 3 tri, and so on and so forth. Okay. We'll drop the last A, let's say in tetra, this A, and penta, this A here. So we'll drop that if the name of the second element or non-metal begins with vowels. Okay, so those are the rules for prefixes. Okay, naming binary molecular compounds. Binary, of course, just means only 2 non-metals here. Okay, so we simply write the name of the first element in formula, and we use the full name of the first element. Step number 2, we'll write the base name or the stem or the root of the second element's name in the formula, then with a suffix IDE. Number 3, use a prefix in front of each name to indicate the number of items in that compound. Never use the prefix mono on the first element. Okay, so that's the first one. First element is the second element. And let's take a couple of examples. So here, Xe, okay, the prefix for the first one, there's nothing. So therefore, we just write the first name, the full name of the first element. So it's xenon. You see, we don't write down mono because it's the first element and just 1 item there. Okay, for the second one, prefixes is the subscripts. So, and that's 6. 6, the prefix is hexa. Okay, then plus the base name or stem or root of the name of the second element. And the second element is fluorine. So we use the stem or the beginning few letters FLUOR, then IDE. So fluoride. We don't write down fluorine. We write down fluoride. We follow this rule right here. So therefore, you put them together. That's xenon hexafluoride. That's the name for this formula. Another one. So the first element is nitrogen, and the prefix 2 means di. Then the full name of the first element. So therefore, it's dinitrogen. Then the second one, the prefix should be tetra. And then you don't say tetraoxygen, you say tetraoxide. You use the base name, then plus IDE, or in other words, use the anion name, okay, tetraoxide. But here you see the tetra, T-E-T-R-A, the A is not used because the name of the second element starts with O. Let's work on another example, naming binary molecular compound SF6. First, name the first element, sulfur, use the full name. Name the second element using the anion's name, fluoride. Then add a prefix to each name to indicate the number of atoms in the formula or the subscript. Sulfur, there's only one, but we don't use mono because it's the first element. Then for fluoride, there are 6, so we call that hexafluoride. So therefore the full name for this formula should be sulfur hexafluoride. Writing formula for binary molecular compounds from name: dinitrogen tetrasulfide. Now we are writing formula from names. What do we do? First, identify the symbols of the elements. Nitrogen, from periodic table, you know, it's N. Sulfide, you know, is from sulfur, and sulfur's symbol is S. Write the formula using prefix numbers for subscript. Of course, di means 2, tetra means 4. So therefore, 2 nitrogen, 4 sulfur, N2S4. That should be the formula for dinitrogen tetrasulfide. More practices. Name the following molecular compounds. Okay, this is from formula to names. Okay, we have 2 nitrogen and 5 oxide. Therefore, should be dinitrogen pentoxide. We have 1 iodine. We don't say mono. We just simply say iodine trifluoride. And for the third one, again, we don't use mono. We just simply say antimony pentachloride. That's from formulas to names. And now, from names to formulas. Tricarbon tetraphosphide. Tricarbon, which means 3 carbon, C3. Tetra means 4. Phosphide comes from phosphorus, so therefore should be C3P4. Sulfur hexabromide. Sulfur is S. Bromide comes from bromine, Br, and 6 of those. Krypton tetrachloride, KrCl4. Yeah, those are the examples for both from formula to names and from name to formulas. Acids. Acids are molecular compounds that form hydrogen ions or protons when they dissolve in water. So therefore, it's important you write AQ means aqueous. So it simply means, you know, the substance is dissolved in water. Okay. One example here is HCl. But if you see AQ, it means it's actually dissolved in water. It becomes an acid. So therefore, this is a hydrochloric acid. But if it does not dissolve in water, let's say HCl, if it's in gaseous phase, it's not an acid. Of course, you have to call that using the rules we just talked about a short while ago. The first one is hydrogen. We don't say mono because it's the first one. And the second one is a chloride, but we have to use mono on the second one. So therefore, it should be hydrogen hydrogen monochloride. Okay, so with AQ it's an acid, without AQ it's not an acid. Strong acids are very, very corrosive. So when you work in the lab, you make sure you have to take care of yourself, so don't get hurt. And the formula for acids should start with H. Okay, you see every one of those starts with H. And of course they contain protons, so or hydrogen cation and an anion. Let's say in this case, of course, the anion is chloride. In this case, the anion is sulfate, and here the anion is nitrate. Binary acids has a hydrogen ion cation and a non-metal anion. Let's say hydrochloric acid, you see right here, that's just a binary acid, okay, has a cation which is H+, and then a non-metal ion, in this case is a chloride. But the oxyacids, they have cation, they have a H+ as the cation, but then the anion is a polyatomic anion, like SO4 sulfate, NO3 nitrate, and so on and so forth. Yeah, naming binary acids. So we simply follow these 4 steps, okay? And I'm going to explain this using this example. Name the acid HCl, AQ. Okay, step number one, write hydro as a prefix. Step number 2, write the nonmetal base name. So the nonmetal's name is chlorine. Then we'll just use the base name, or we call that stem or root, CHLOR. And then we'll end the name and this name, the one name, with IC. Okay, you see? Hydrochloric. And then we just add another word, acid, at the end. That's the way we name binary acids. HCl is called hydrofluoric acid. Okay, how to write a formula from the name of a binary acid? Let's work on the first example. Find the formula for hydrosulfuric acid. Okay, you have to remember, in all acids, the cation is H+. And if you see the prefix hydro, it means binary. It means binary. Those acids, they do not contain polyatomic ions. Okay. So step number 1, write the symbol for the cation and its charge. Cation is hydrogen ion and the charge is +1. Write the symbol for the anion and its charge. The anion is sulfide. The charge is 2-. Charge without sign, plus or minus, so without sign, charge becomes subscript for other ion. What does it mean? You see? So the charge for hydrogen is +1, therefore the subscript for S is 1. It's 1. If it's 1, we don't write it down. And then the charge for sulfur is 2-. we will just simply use 2 without sign. You see, we just use the absolute value as the subscript of the other ion, which is hydrogen. That's why it's H2S. Then you add AQ to indicate it dissolved in water, then it is an acid. Otherwise, this will be just dihydrogen sulfide. You see, it's not an acid if you don't write down AQ. And then you check the total charge of the cations cancels the total charge of the anions, so that this acid molecule carries an overall charge or net charge of 0. Let's do more practice. Name the formula for the following binary acids. HFAQ means it's an acid, and it's a binary acid. So the 2 ions are H plus and fluoride. So therefore, the name has to start with hydro because it's a binary. Hydrofluoric acid. HBr, hydrogen ion and bromide, hydrobromic acid. Remember, you have to use IC as the suffix in binary acids. And now, let's find the formula from the following binary acids, which means let's do from names to formula. Okay. Hydroiodic acid. Identify the ions. Hydrogen iodic, that's iodide. Okay, iodide. So therefore, you see, that should be just HiAQ. Hydrochloric acid, hydrogen and chloride. So therefore, should be just HClAQ. Hydroselenic acid, hydrogen and selenide, Se2 minus. And then make sure the charge becomes the subscripts of the other ion. That's what we did here. And then also AQ. So that's from formula to names, and from names to formula. So you should be able to work with those nomenclature problems. Now, oxyacids are the ones containing oxygen. Okay, so let's work on the first example, HNO2 AQ. Okay, and obviously NO2, that's a polyatomic anion. Okay, identify step number 1. Identify the anion by separating the hydrogens. You see, HNO2, after separating the hydrogen ion, you have NO2 minus. From previous lectures, we know this is nitrite. If polyatomic ion name ends in ATE, remember nitrate is NO3, but this one is not nitrate, it's NO2, this one is nitrite. But if it's ending with ATE, we use IC as the suffix. But ending with ITE, like in this case here, we use OUS as the suffix. So therefore, the anion in this formula, in this acid, is nitrite. If it's nitrite, then the acid's name should be ending with OUS, nitrous. Okay. Write the word acid at the end of all names. So nitrous acid. That's how you name oxyacids after you see a formula of oxyacids. So this is from formula to names. Now write the formula of an oxyacid from its name. Okay, when name ends in acid, the formula should always start with H. Write formulas as if ionic, even though, of course, it is molecular, so they are not ionic compounds. Acids are not ionic compounds. Okay. Hydro prefix means it's a binary acid. No hydro prefix means it is an oxyacid. Okay, just two types of acid. Then you should be able to tell the two by just seeing whether there is a hydro prefix in it. For oxyacid, if ending is IC, then the polyatomic ion should end with ATE. If the ending is OUS for the acid, then the ion, the suffix should be ITE. Write the formula for carbonic acid. Again, all acids, they have to contain hydrogen ions, so that's a cation. In the name, I don't see hydro. No, hydro means polyatomic ion. And now I see in this name the suffix is IC. IC means ATE. Okay, so once you understand all of this, solving this problem is a very easy one now. Write the symbol for the cation and its charge, H+. Write the symbol for the anion and its charge. Of course, that should be carbonate, 2-. And then charge becomes subscripts for other ion. Okay, so that's why hydrogen now you have 2 because the charge for carbonate is 2-. And then for carbonate, you have just one carbonate, 1 CO3 because the charge for the other ion H is 1. Add AQ. So that's it. You see, that's the formula. And then again, you can double check the total charges for the cation and anion. They should be cancel each other, or the overall charge for the molecule should be 0. Let's talk a little bit more about the oxyanions. Okay, we have a few columns here. So the first column is a number of atoms, and then the second one is a prefix. And some of them, they don't need a prefix, okay? And now the stem, root, or base names, all right? And then comes the suffix, okay? You see those plus sign means that all 3 parts should be just one word. All 3 parts should be just one word, okay? And here are the examples, and here are the names. Okay, let's take a look. The number of oxygen atoms. Let's start from the highest one to the lowest one. Okay? So, this is the first one. ClO4, 1- or -1. That is 1 oxygen atom more dichloride. And if it's one oxygen atom, more than chloride, we use a prefix per. That's why it's a perchloride. And then this one is just chloride. How about one oxygen atom less than chloride, or than the one ending with ate? You already learned this. It should be just ite. That's why this one is chloride. Then how about one oxygen atom less than the one ending with ite? It's still ite. It's still chloride in this case, but we use hypo. Okay, so therefore the last one is hypochlorite. Okay, and all the halogens, they should follow the same pattern. It's not just chlorine. You can replace Cl with Br. You can replace Cl with I. And of course, if you replace Cl with Br, this one would change to bromate. Hypobromite. Okay, more practices. What are the formulas for the following acids? Perfluoric acid. So, of course, the cation is a hydrogen, and then the anion, perfluoric, which means has one more oxygen than the one with ate. So therefore, it should be O4. And since it's, the stem or the root of the name is FLUO, so therefore it should be fluorine in here. Okay, and now you just have HFO4, phosphoric acid. So hydrogen ion, and then from phosphoric acid we know the anion has to be ending with ate, then it has to be phosphate. This is phosphate. Okay, and now is the formula. Bromous acid, OUS, means the anion has to be one oxygen less than ate. Ate, there are 3 oxygen atoms, and this has to be one less than 2 oxygen atoms. And the polyatomic anion here is BrO2. All right, it's a bromide. So HBrO2, that's the formula. Hydroiodic acid. Hydro, whenever you see the prefix hydro, it does not contain polyatomic anions. Okay, it should be just a binary acid. Okay, so HI. Strictly speaking, we should add AQ after all of those formulas. Okay, just make sure you understand that. This is the end of lecture 12 quizzes. So again, I will work on the first one with you guys. Give the name of aqueous HI. Okay, so obviously that's a binary acid. We should see the prefix hydro first. Okay, and if I look at those choices here, only B starts with a hydro. Okay, and here you say that's also hydro, but that's actually hydrogen. That's really the hydro here is not prefix, all right? So therefore B should be the correct answer. And what is wrong? What is wrong with the hydrogen iodide? Okay, so here's aqueous. Hi means it's an acid. So if it were not an acid, you can call that hydrogen monoiodide. All right, so that would be correct. Yeah, so B is the only correct answer. The others are incorrect. And of course, you will work on the remaining ones. And I will see you guys in lecture 13.